Welcome to Quantified Software. Today we're going to be talking about batch size in software. Today we're going to be talking about batch size in software. This is something that we usually don't talk about, of choosing our batch size in an economic frame. So this is something that has been known about in economics research and operations research since the 1900s. There's the concept of economic order quantity, or EOQ, developed in the early 1900s. There are several different types or variants of this formula. One of the ones for software that's the most applicable is what is called the economic production quantity. It gives you a sense of how trade-offs in batch size and setup cost can find an optimal batch size. So your holding size, your setup costs, and your total costs. So today we're trying to develop some intuition about that. One way to do that is to use a great tool called Desmos. It's an online graphing calculator. So we can jump into Desmos and start a new graph, and we'll do EOQ video. So what we are trying to graph is a total cost per unit with a slider here on K. Well, the negative numbers don't quite make sense, so let's set some boundaries here on K. Our batch cost is not going to be less than 0, and let's say that it goes up to 8 steps of quarter. Then here, that makes more sense. The graph here doesn't quite make sense showing negative batch size, so let's make that down to there, and we can do a step of 1. So the x-axis is going to be batch size, and the y-axis is going to be item cost. And again, the cost is never going to be negative. Let's do 8 with a step of 1 again. So now this gives us a sense of the item cost as we change vary the batch size. And maybe we do want a little bit of a smaller scale here. Y-axis 0 to 0. Okay, great. Now, after this, we're going to want to also plot our holding costs, which the average holding cost per item is going to be the holding cost per item over 2, because each item is held on average half the time of the time of the batch. So again, holding cost doesn't make sense to go negative. We can set this something that seems reasonable, number of hours per unit time that we're going to spend. And then we can see the trade-off here on holding costs increase linear with batch size, whereas as we decrease the total cost for the batch, it decreases our per item cost for that batch. And now we just need to put them together. So we can say y3 is going to equal y1 plus y2. And now we have, well, let's also put the optimal here. We can put a line where, if we're minimizing, that's where we're going to find an optimal. We can do find the derivative of y3. And we can even put an optimal marker, which is going to be square root of 2k over h. And let's just put it on the x-axis. We can mark a label, call it optimal. So now we can start to get a sense of optimal batch size for different holding costs and for different total batch costs. So as you can see, if our holding cost is an hour, or maybe let's make it an hour per item per week. Let's say we're doing weekly iterations, and the total cost of a deploy, if it costs you an hour to do a deploy, that would be the batch in this case, your optimal batch size is going to be right here at about, what is that, 1.4, call it. But notice how this black curve, Y3, the total cost per item, is minimized in a very shallow U curve here. So anything between 1 and 2 actually gets you very close to the optimal batch size. And we can also have some intuition of as our holding costs go up and increase, it drives our optimal batch size down. It takes a very high batch size or cost per batch. This would be the equivalent of 4 hours per deployment to start pushing us up over a few items in that batch. So if we're thinking of ourselves in a CI/CD continuous deployment world, it's not crazy to think that our cost of a deployment could be 15 minutes. Holding costs, again, even if they're very low and you squeeze out a lot of holding cost for each item, you're still optimal right around 1. So this really gives you some intuition about how batch size works. We'll talk more about how this interacts with cost of delay. Hopefully that was a quick explainer on how economic order quantity or economic production quantity is useful in thinking about how to size your deployments for software. As always, would love to hear your feedback. What have you seen in your experience where you've worked? How have you thought about batch size and how to choose your deployment sizing? Do you think that you chose in a way that was economic, or do you think you chose from your gut based on what people felt would be easiest or hardest? Fascinated to hear your feedback. Give us a comment below and please subscribe. This is Quantified Software.